Okay, number 47. For the following exercises, determine whether the function is even, odd, or neither. Well, here's how you determine that. If you take f and put negative x in there and get f of x, same formula again, that means it's even. And if you get negative f of x, then that's odd. Alright? So that's the basic procedure. So on this one we have f of x. Let me wall this off here. F of x equals 3x to the fourth. So try f of negative x, see what happens. That equals 3 negative x to the fourth, which equals 3 negative 1 times x to the fourth, which equals 3 negative 1 to the fourth and x to the fourth, right? Remember, in parentheses, ab to the nth power is equal to a to the nth times b to the nth, alright? So 3, and then negative 1 to any even power is positive 1. And then x to the fourth. 3 times 1 is 3, so that's just 3. X to the fourth, which is the same as f of x. So f of negative x equals f of x, which means it's even. Alright, even. Number 49, we have h of x equals 1 over x. H of x equals 1 over x plus 3x. Okay, so what's h of negative x? Oops, negative x. So that's equal to 1 over negative x plus 3 times negative x, or negative 1 over x minus 3x. There you go. That's the negative of h of x, right? If you take the negative of this whole thing, you get this. So that's negative h of x. H of negative x equals negative h of x, and that's odd. Alright, odd function. Number 51. We have g of x equals 2x to the fourth. So let's try g of negative x. So that's 2, and then negative x in parentheses to the fourth. And that's 2. Negative 1 times x to the fourth in parentheses. And that's 2, negative 1 to the fourth, x to the fourth. So negative 1 to the fourth is 1. So that's 2 times 1 times x to the fourth, and that's equal to 2x to the fourth, which is g of x. So g of negative x equals g of x, which is an even function. Alright? Number 53. For the following exercises, describe how the graph of each function is a transformation of the graph of the original function f. So we have g of x equals negative f of x. Or you could divide both sides by negative 1. Think of that as y equals f of x, or negative f of x, and now you have y over negative 1. So what this does is cause a reflection in the same direction as the y-axis, like this, since it's underneath the y. And that's a reflection across the x-axis. So this is the reflection of f of x across the x-axis. Number 55. G of x equals 4 times f of x. So you can divide both sides by 4. So you have g of x over 4 equals f of x. Or if y equals 4f of x, then y over 4 equals f of x. So it's under the y here. So the 4 affects all the y coordinates in the original graph f of x. And it multiplies each y coordinate in the original graph by 4. Alright, so what that's doing is it's causing a vertical stretching of the graph. In the previous problem there was a -1 under there, and you could think of multiplying each y coordinate in f of x, the original f of x, by -1, which would cause a point to reflect across the x-axis. Alright, the positive y value would become a negative y value, and vice versa. A negative y value would become a positive y value. So that would be a reflection across the x-axis. Alright, so this has the effect on the y coordinates of the original function f of x, and it causes a stretching vertically by a factor of 4 in f of x. Okay, number 57. G of x equals f of 5x. Now this f of 5x can be written like this: x divided by 1/5. F of x divided by 1/5. Alright, both of these are equivalent. So what does that do? It's the 1/5 here is under the x, so think horizontal things are going on. Alright, so this is multiplying each x coordinate in the original f of x by 1/5, or dividing each x coordinate by 5. Alright, so what that's doing is it's causing a horizontal shrinking or compression of f of x by a factor of 1/5. Okay, so it's, or rather by a factor of 5, it's compressing it. Okay, so just think of multiplying each x coordinate in f of x, the original f of x, by 1/5. And that'll give you the resulting graph here, g of x. Alright, so there you go. Number, excuse me, 59. We have g of x equals f of 1/3 x. So if you think of 1/3 times x as x divided by 3, or x over 3, so it's f of x over 3. So we have the 3 under the x here, and so think horizontal. And what is it doing? This is multiplying each x coordinate in the original function f of x. Each x coordinate is being multiplied by 3. Okay. So what is that doing? That's causing a horizontal stretching. All right, a horizontal stretching. So each x coordinate in f of x is multiplied by 3. All right. There you go. Number 61. we have g of x equals 3f of negative x. G of x equals 3f of negative x. So what I'm going to do is divide both sides by 3 first. So you get g of x over 3, and f of that equals f of, and instead of negative x, I'm going to write x over negative 1, which is equal to that. Alright? Because why? Negative 1, well, let's start with negative x. Negative x equals negative 1 times x, and that equals 1 over negative 1 times x, right? You could write that the other way as negative 1 over 1 too, and this is equal to x over negative 1, alright? So there's the mathematical reasoning for that, as if you didn't know already, right? Well, I have to be sure, you know, I have to be sure, make sure everybody's on board here. Okay. So, what does this do? This is under, think of that as being y equals g of x, okay, so 3 under the y, think vertical, and it's multiplying each of the y coordinates in the original f of x by 3. And what that's doing is it's causing a vertical stretching by a factor of 3. This, over here, is multiplying each x coordinate in f of x, the original f of x, by negative 1. And what that results in is a reflection going in the same direction as the x-axis or across the y-axis. Okay, so it's a reflection. It's not changing the absolute value of that coordinate, the x-coordinate, because it's a 1 here, but it's a minus 1, so it's changing the sign of the x-coordinate, of the x-coordinates in the original f of x. Alright, so what we're having here in general, to sum it up, is a vertical stretch by a factor of 3 and a reflection across the y-axis. Alright? Number 63. For the following exercises, write a formula for the function g that results when the graph of a given toolkit function is transformed as described. So we have the graph of f of x equals absolute value of x is reflected over the y-axis and horizontally compressed by a factor of 1/4. Alright? So let's see, so g of x then is equal to, well, let's see, it's reflected over the y-axis. In other words, it's going in this direction, right? The same direction as the x-axis. So I'm going to apply something to the x in absolute value of x. And it's horizontally compressed by a factor of 4, or it's stretched by a factor of 1/4, you could put it that way. Alright, so it's actually, so that would be a compression or a shrinking. So again, this is horizontal, so I'm going to apply something again to x inside of absolute value of x. So I'm going to divide x by the negative something. Negative will take care of the reflection. And the shrinking by 1/4 is achieved by that there, 1/4. So it's actually x divided by negative 1/4. Alright, x divided by negative 1/4. So think of each x coordinate in the absolute value of x, each x coordinate being multiplied by -1/4, alright, and that will achieve a reflection across the y-axis, and also it'll shrink the graph horizontally, alright. So we can simplify this a little bit with algebra. You can invert and multiply by the numerator, invert the denominator, multiply by the numerator, and that gives you a -4x inside the absolute value bars. This is in your book. This is the answer in your book. This can be simplified further if you think of -4 is -1 times 4x. -4x is -1 times 4x. And this is equal to absolute value of -1 times absolute value of 4x. Alright. And absolute value of -1 is just 1, so it's just absolute value of 4x. Okay. So you can even go further with this. Shall we get crazy here? This is absolute value of 4 times absolute value of x. Alright. And absolute value of 4 is 4, so it's just 4 times absolute value of x. So you can go a little bit further with that than the book gives you. Alright, so you could do that if you wish. If you don't believe this is the same as this, just graph them on your graphing calculator. Alright, and you'll see. They are the same graphs. The rule I used here is, and I've mentioned this before, but it bears repeating, absolute value of a times b is equal to absolute value of a times absolute value of b. Alright? That's a rule that you can use. Okay. Number 65. The graph of f of x equals 1 over x squared is vertically compressed by a factor of 1/3, then shifted to the left 2 units and down 3 units. So we're going to write, for the new function, we'll call it g of x. And you could also think of that as y equals g of x, if you wish. Now the vertically compressed, vertical, meaning it'll be under the y equals g of x, okay, the number that I'm going to use here. Vertically compressed by 1/3. Alright. So that'll accomplish that. It multiplies all the y coordinates in the original f of x equals 1 over x squared. All the y coordinates are multiplied by 1/3. Okay? And so that'll give you your vertical compression or shrinking. And it's shifted to the left. That would have to do with the x in the 1 over x squared. I'll get to that in a minute. And down and up. That's the direction of the y-axis, down and up, right? So that's going to be right next to the y here. Y minus, and then your shift. Down would be -3, right? So remember the format. It's always y minus, and then whatever that number is. If it's negative, it's down. If it's positive, it's up. Same thing applies to the x when we get to that point. Alright, now this is 1 over x squared. 1 over x squared, but we're going to do something with the x. So I'm going to leave some room here, put parentheses around it. And it's shifted to the left 2 units. So left would be a negative. So it's going to be x minus whatever the shift is. Alright, it's a -2 because it's shifted left 2 units. If it were shifted right, it would be x minus 2. If it's shifting left, it's x minus a -2. Alright, so x minus -2, and there's your, what used to be 1 over x squared. Alright, so this gives you your vertical shrinking by 1/3. This gives you your shift down 3 units, and this gives you your shift to the left 2 units. All right. So you can multiply both sides here by what I want to do is clear this out. Okay, so you can multiply both sides by 1/3. And that becomes g of x plus 3 here on top, right there. And that equals 1/3 over, and I'll change that to x plus 2 squared. All right. And so subtract 3 from both sides, and you get g of x, and 1/3 times this over 1. Flip that over, multiply by that. You're going to get 1 over 3 times the quantity x plus 2 squared. And then you subtracted 3 from both sides, so that goes over here. All right. So there's your resulting graph, or formula for your function. Okay, number 67. The graph of f of x equals x squared is vertically compressed by a factor of 1/2, then shifted to the right 5 units and up 1 unit. Okay, so let's deal with y equals g of x here. G of x is our new shifted graph, and let's see. What's the this vertical compression by a factor of 1/2? Okay, so what do we got? That's divide that by 1/2 under the y. Think of that as y equals g of x. So you multiply each y coordinate in f of x by 1/2. So that'll give you your vertical shrinking or compression. All right, and shifted to the right, we'll deal with that later because that has to do with the x value, or the x variable, and shift up 1. So think of that being as y minus 1, right? That'll give you your shift up 1. All right, remember the format, it's always y minus something, or it's x minus something. Okay, so if this number here is positive like it is, it's up. If it's negative, it's down. Okay, and it's shifted to the right 5 units. So let's get to that part. That's got to do with the x here. It's x. It was x squared. Y equals x squared, or f of x equals x squared. But now we're going to shift to the right. So it's x minus 5, right 5 units squared, like that. All right. So that's basically it. Now all we have to do is simplify it, kind of massage it a little bit to get it into something that's nice to work with. So you multiply both sides by 1/2. All right, so you get g of x minus 1 equals 1/2 times the quantity x minus 5 squared. And then you can add 1 to both sides, finally getting g of x is equal to 1/2 x minus 5 quantity squared plus 1. Alright, so that's our final result. Okay, number 69. For the following exercises, describe how the formula is a transformation of a toolkit function. Then sketch a graph of the transformation. I'm going to skip that part and show you the printout from the answer section, all right? But I will go over a few points and how they transform and write those down for you, and you can just plot those points and get a nice graph. But you know, it's kind of a pain to draw coordinates, x, y axes, and you know, get everything nice and neat on this board freehand. So I'm going to refer you to the picture, but in the book. So we've got a formula here, g of x equals 4 times parentheses x plus 1 close parentheses squared minus 5. All right. I'm going to look at this as being y equals g of x. Let y equal g of x. So what we've got is, now I'm going to subtract negative 5 from both sides or add 5 to both sides. All right. So you've got y, I want to get it in the right format, y minus negative 5, all right, equals 4, and then you've got, write that as x minus a negative 1. So there's our format to help us see what's going on. And then divide both sides by 4. So you've got y minus negative 5 over 4 equals x minus negative 1 quantity squared, like that. All right. So this 4 down here under the y is causing a vertical stretch by a factor of 4. All right. This negative 5 next to the y is causing it to shift down 5 units. Okay. And this next to the x here, the negative 1, is a left shift to the left by 1 unit. All right. So let's see what happens to the points 0, 0, 1, 1, negative 1, 1, 2, 4, and negative 2, 4. Now these are all points on f of x. Points on f of x equals x squared. So let me block that off there. All right. What happens to these? Okay. So take 0, 0. Well, first of all, do you agree that these are points on y equals x squared? All right. If you take the x coordinate and square each x coordinate, you get the y coordinate here, right? So I think we can all agree that those are points on the original f of x equals x squared. Okay. So what happens to them when we apply these transformations? So let's try 0, 0 first. What does that do step by step? Well, when you do these transformations, do the stretching and the shrinking and reflecting first before you do the shifting left, right, or up or down. Okay, so there's an order of operations here. Sometimes you'll end up with a different graph than the correct graph if you do it the other way around. Okay, so think of an order of operations. When you do order of operations, you do multiplying and dividing before you do adding and subtracting, right? So it's kind of the same idea here. All right. So there isn't an official order of operations. They don't call it that here, but I'm using that as an analogy, all right, to help you remember. So do this first. All right. What does that do? That multiplies each y coordinate in the original function by 4. Well, what happens here? Let me write it. Well, yeah, let me write times 4 here. Times 4. All right. So you multiply the y coordinate by 4. So that doesn't mean 0.4. That means times 4. All right. So just bear with me with this crazy notation. All right. So 4 times 0 is 0, so nothing happens. All right, the origin or the vertex stays the same so far. All right. Now, since we're over here dealing with the y coordinates, let's do this next. Now it doesn't matter which one we do next. After we've done all the reflecting and the stretching and the shrinking, now we can do the shifting left, right, up, or down, and it doesn't matter which one of those you do first. All right, so let's do this first. This is a shift down. So you add -5 to the y coordinate. Add -5. So arrow, I'm going to put a -5. And you just remember that means add -5 to the y coordinate here. So 0 minus 5 is -5. So you get 0, -5. Alright? Alright, we're almost done. Now over here, we've got to add -1 to the x coordinates. Alright? So you add -1. Just remember that's to the x coordinate. Alright? So 0 use this point here that we've just got done with. 0 minus 1 is -1 and -5. So the origin or the vertex is now -1, -5. Let me draw that up there. The end result. All right. So far, so good. How about 1, 1? 1, 1. I'm going to go in the same order so I don't have to rewrite all these. All right. So you're going to multiply each y coordinate by 4. So 4 times this y coordinate here, of 4 times 1 is 4. So you got 1, 4. Okay, now I'm going to add -5 to the y coordinate. This y coordinate here, not to the original. All right. So you do these operations to the point that you just transformed. All right, not to the original point. So you're going to go -5 plus 4 is -1. So you got 1, -1. And then you've got a -1 adding that to the x coordinate this time. -1 plus 1 is 0. So you've got 0, -1. Alright, so 1, 1 goes to 0, -1. Alright. Now I know this is taking some time, but who's going to spend this much time with you unless you hire a private tutor, right? So you can call me your private tutor. And I'm doing this for free, so it will pay you to just bear with me here, have a little patience, and you will learn a good amount of stuff here. This will help you on a test for sure. Alright, so next point is -1, 1. I know your teacher doesn't have time, maybe even during office hours, because they may have a line of students outside their door waiting to get in with their questions, and so they're not going to take this much time on one single problem, all right? Or in class too. They might do that, but they have other things to cover, you know. They're human beings. We're all human. We don't have all this time, right? But I have plenty of time. I'm retired and I'm taking all this time on YouTube, so it's a doable thing. Anyway, we've got multiply 4 times the y coordinate. So you're going to get -1, 4. Okay, now this, you add -5 to the y coordinate. So you're going to get -1 there. So -1, -1. And then you're going to add -1 to the x coordinate. So that becomes -1, -1 equals -2. So we have -2, -1. Alright, that's what happens to -1, 1 on the original. Okay, how about 2, 4? So you multiply the y coordinate by 4. That becomes 2, 16. Alright? Now you add a negative 5 to the y coordinate. This one here. Alright? So 16 minus 5 is 11. So you got 211. And now you add negative 1 to the x coordinate. So 2 minus 1 is 1. So you get 111. 111. Alright. Okay, one more. Negative 2, 4. Multiply the y coordinate by 4, so you get negative 2, 16. Now you add negative 5 to the y coordinate, so 16 minus 5 is 11. So that gives you negative 2, 11. And finally, you add negative 1 to the x coordinate. So you go negative 2 plus negative 1 equals negative 3. And 11. Negative 3, 11. All right. So there you go. What you do is you plot these points here on the right side, and then you can connect the dots with your parabola, your smooth curve. All right. So what you'll end up getting, if you do a really neat job, is something that should look exactly like this. All right. Or pretty close. That's the one in your book. And you can confirm, if you look in your book, you can confirm that these points are on the new graph. I've already done that, all right? So there you go. And that's I've done more points probably than necessary to actually get the shape of the new graph. So, you know, when you actually do this yourself, if you like doing it this way, then you can just do fewer points and still get a pretty decent graph probably. At least get the vertex, and at least get 2 points on either side of the vertex, kind of a little ways away from the vertex, and that'll give you a good idea of how to draw a parabola at least. All right. So yeah, this I like this method because there's no doubt about what's going on. You know, when you could do it this way, just think about it in your head and kind of draw a mental picture of that. You can do that with when you get a lot of practice with this, but when you get strange functions, or sometimes they'll give you a function, a picture of a graph with no formula, and it's a weird graph, and you can just take some points off of that graph and apply the transformations like I did here and draw your new graph, and that way it's pretty cut and dried. All right. Okay, number 71. Let's see, we've got h of x equals negative 2, absolute value x minus 4 plus 3. So I'm going to write y equal h of x, let y equal h of x. So I've got y equals all that, so I'm going to first subtract 3 from both sides. So you got y minus 3 equals negative 2, absolute value of x minus 4. And then I'm going to divide both sides by negative 2. All right, so you've got y minus 3 all over negative 2 equals absolute value of x minus 4. Okay. So what do we got going on here? Alright, let's look at this first. That is going to multiply each y-coordinate in the absolute value of x. Each y-coordinate is multiplied by -2. So what is that going to do? That's going to cause a reflection across the y-axis, or going in the direction of the across the x-axis rather, or going in this direction, right? Same direction as the y-axis. So across the x-axis, and you're also going to cause a stretching to go on. All right. Okay. This y minus a positive 3. Right? Remember the format y minus, x minus. So y minus positive 3 means you're going to have a shift up 3 units. All right. And then over here you've got x minus 4 in absolute value bars. X minus something, right? That something is a positive 4, so that means you're going to shift to the right 4 units. Okay? So let's see what happens to some points on y equals absolute value of x. So you have the point 0, 0 on the original absolute value function. Alright. Again, do the reflecting, the stretching, and the shrinking first, and then do the shifting. Alright, so I'm going to put a -2 over here, and you'll know what that means because that's, you're going to multiply each y-coordinate by -2, right? Just look at the this formula here. So -2 times 0 is 0, alright, so 0, 0. And then the shift up, you're going to add 3, so I'll put +3 to the y-coordinate. Alright, so 0 and 3. And then over here, you're going to add 4 to the x-coordinates. So I'll put a +4. So 4 plus 0 is 4, so you get 4, 3. Alright, so 0, 0 is now 4, 3. Okay. How about 1, 1? Multiply the 1 by -2, the y-coordinate here, by -2, and you're going to get 1, -2. Then you add 3 to the y-coordinate. 3 minus 2 is 1, so you're going to get 1, 1. Then you add 4 to the x-coordinate. That becomes 5, 1. So 1, 1 becomes 5, 1. Alright, and then let's do just one more. That should be plenty. -1, 1. Do we all agree that's on the original absolute value function? Yeah. Okay, so, and if you don't agree, go back and think again. Alright, so multiply the y-coordinate by -2, so you get -1, -2. Now you add 3 to the y-coordinate. 3 minus 2 is 1, so that's -1, 1. Wow, back to where it was. But it's not done yet. Now you add 4 to the x-coordinate. 4 minus 1 is 3, so you get 3, 1. Alright. So, you're going to get, what you do is you plot these 3 points and then fill in the rest of the graph. You know the vertex of the absolute value function was 0, 0, and this is your new vertex. So you start with that point and then plot those other 2 points and then connect the dots with your straight edge. And you will get, or you should get, this result. And you can check that the points that we calculated are on here. And there you go. Okay. Number 73. M of x equals 1/2 x cubed. So this is taking your toolkit function y equals x cubed and doing some transformations here. So I'm going to call that y. Let y equal m of x. And so we're going to have y equals 1/2 x cubed, and then divide both sides by 1/2. So like that. Alright, this doesn't look too bad. Alright, it's pretty simple. One thing going on. You take the original y equals x cubed and you multiply each y coordinate by 1/2. Alright, so because that's under the y there, multiply each y coordinate by 1/2. Okay, so in other words, you're shrinking or compressing the graph vertically by 1/2. Okay, so let's take a couple of points that are on the original graph, y equals x cubed. For example, we have the points -2, -8. -2 cubed is -8, so this is on the original graph, y equals x cubed. And then I'm going to multiply the y coordinate by 1/2. Alright, so that's 1/2 times -8 is -4. -2, -4. Okay. Another point on the graph y equals x cubed is 2, 8. Multiply the y coordinate by 1/2, you get 2, 4. Alright, so that's pretty much all you need. If you know the general shape of y equals x cubed, you can graph a couple more points if you wish. But these are the points that you'll plot first, and then you can connect those dots with a nice curve and in the shape of y equals x cubed. Alright, 0, 0 is also on the original graph. You multiply 1/2 times the y coordinate 0 and you still get 0. So the origin, or the graph, passes through the origin again. So what you get is this result. Number 75. Okay, let me draw this out or write this down. P of x is, in parentheses, 1/3 x, close parentheses, cubed, minus 3. So I'm going to let y equal P of x. Alright, so we've got y equals 1/3, not negative 1/3, 1/3 x cubed minus 3. Now I'm going to subtract -3 from both sides. Y minus -3. I'm not saying add 3 to both sides because I want this format, minus something, y minus something. And that equals, I'm going to write in parentheses x divided by 3, which is equivalent to 1/3 x. And there's your cube there. So we're transforming y equals x cubed. So what is this doing? This part right here is causing, multiplying each x coordinate in the original y equals x cubed. Each x coordinate is multiplied by 3. So that's causing a vertical, not a vertical, but a horizontal stretch. Alright? And this, next to the y, is a shift down 3 units. So you do this one first, and then you do that one. And let's take some points on the original graph. Let's say 0, 0 is on y equals x cubed. I'm going to do that first, so I'm going to multiply by 3 times 3. I'm going to multiply the x coordinate by 3. Alright? That's under the x there. So 3 times 0 is 0, so you still get 0, 0. And now I'm going to do this shift down 3 units, so subtract 3 from the y coordinate. So you're going to get 0 minus 3 is negative 3, so it's 0, negative 3. Alright? So that's what happens to 0, 0. On the original graph, it becomes 0, negative 3. How about 2, 8? 2, 8 is on y equals x cubed. Again, multiply the x coordinate by 3. I don't need to redraw that. It's same as what I've got here. Alright? So the x coordinate this time is multiplied by 3, so that becomes 3 times 2 is 6. So you get 6, 8. And now you're going to take this, negative 3, and add it to the y coordinate here. Alright, so 8 minus 3 is 5. So you get 6, 5. One more point. Let's see. Negative 2, negative 8 is on y equals x cubed. Again, multiply the x coordinate by 3, so you get negative 6, negative 8. Now you add negative 3 to the y coordinate, so you get negative 11. Alright, so you get negative 6, negative 11. Now you plot those 3 points at least. You can do more if you wish. And then connect the dots with a nice curve in the shape of y equals x cubed. And you will get this result right there. Number 77, we have a of x equals square root of negative x plus 4, all under the radical. Now, one little thing to watch out for here. This is not in the correct format, all right, for our purposes. Remember, the format would be x minus whatever the number is, x minus h, right? X minus h. Well, what if you have some constant in front of the x? Now, see, notice that the only constant in front of the x is a 1. We just didn't write it there. 1x equals x, so you know, you can imagine there being a 1 there. There's certainly not a 0 there. It's a 1. 1 times x is x. So here we've got a negative 1 though in front of the x. All right, that doesn't fit this format. Okay, so we got to get it that way before we can start thinking about how this is transforming the graph of y equals square root of x. Apparently that's what we're doing here, square root of x. So, for example, if you have, let's say you have ax minus h, where a is some constant other than 1, and it's not equal to 0, of course, because that'll wipe the x out. But let's say this is some constant that you don't want there. All right. How do you get rid of that? What do you do with that? Well, you use a little algebra. You're going to do a common factor of a out of these two terms. But where's the a here? Well, let me go down a little ways here. H is equal to a over a times h, correct? And that equals a h over a. Now we have a common factor of a, don't we? And we can pull that out. And that'll leave you with just h over a. Okay? So I'm going to factor out the a. That leaves me with x minus h over a. Just like I did here. Alright? And I pull that factor in the numerator out, the a. So if you don't believe it, just multiply this back through. A times x is ax. A times h over a. The a's cancel out. That leaves you with just an h. All right. So you can force the common factor if you don't have one, so to speak. All right. If you don't have one, you can force it. All right. And don't worry, the equation's not going to get mad at you. All right, because this is according to the mathematical laws, and they're correct. All right, so as long as you're correct and you're following mathematical laws, you're cool. All right, you're going to be fine. Now, what do you do with this a? All right, well, you write it like this. I've got the x minus h over a, and then write that over 1 over a, like that. All right. So now it's in the correct form. All right. So it's x minus h over a, and this 1 over a here multiplies each x coordinate by 1 over a. Okay. So and this is a shift, either left or right, depending on the sign of h over a. Okay. So if a is negative down here, then it's going to also be a reflection. Okay, so a reflection across the y-axis. All right. So that's what I need to do here. I need to do this kind of common factoring. Okay. So let me do that. I'm going to let y equal a of x. So I've got y equals square root of negative x plus 4. Now I'm going to factor a negative 1 out of these two terms. All right. Where's the negative 1 here? Well, if you have negative 1 times negative 4, that equals positive 4, right? So you can force a negative 1 common factor in this thing. So you're going to get square root of negative, put parentheses, x minus 4, like that. If you want to check that, think of that as negative 1 times x is negative x. Negative 1 times negative 4 is positive 4, so it's correct. So there's your negative 1 in front. Now you're going to put it down below. So you've got x minus 4 over negative 1. Alright? Alright. There you go. So now it's in the nice format and we can see what's going on. Well, everything's going on with the x. Nothing's happening with the y's. So this number here multiplies each x coordinate in the original y equals square root of x function by negative 1. So you multiply each x coordinate by negative 1. Do that first. That's going to cause a reflection across the y-axis, going in the same direction as the x-axis. All right? And then this 4 is a shift to the right, 4 units. So you do the reflection first, then you shift it. All right? And what happens to a couple of representative points? So on the original y equals square root of x, we have the point 0, 0. And let's see. I'm going to apply the negative 1 first. You're going to multiply the y coordinate by negative 1. So I'll put a little dot there, times negative 1. So multiply the x coordinate by negative 1. Negative 1 times 0 is 0. And then I'm going to shift it 4 units to the right. So add 4 to the x coordinate. And that gives you a 4, 0. Alright. And then another point that's quite often used is 4, 2. When x equals 4, take the square root of that, you get 2. Another easy point would be 9, 3, but x equals 9 sometimes goes off of your scale. All right, people often draw a scale from -5 to 5, horizontal scale. So this is a good point to use for 2. You're going to multiply the x-coordinate by -1, so that becomes -4, 2. And then you're going to add 4 to the x-coordinate. All right, so -4 plus 4 is 0. So now we have 0, 2. All right, so you can plot those 2 points, and if you remember what the graph of y equals square root of x looks like, it's easy to fill in the rest of it with a smooth curve. And here's the result, which I graphed on my computer. Okay, 79. Wow, we're getting near the end, folks. Getting near the end. Hold on to your hats. All right, for the following exercises, use the graph in figure 32 to sketch the given transformations. So let me show you figure 32. If you don't have a book, you can use this. That's figure 32, all right? That's f of x. So we're not given a formula, but that's the graph we're going to work with. Okay. That's for 79 and 81. Okay, so 79, we've got g of x equals negative f of x, where f of x is the graph I just showed you. So we're creating a new graph called g of x by transforming f of x. All right, I'm going to divide both sides by -1. So what's happening here, think of that as -1 under a y here. If your y equals g of x, you're going to reflect f of x across the x-axis. It's going to go in the direction of the y-axis like that, all right, or like this, whatever. All right, so it's going to be a reflection. It's not going to stretch or shrink it. It's going to stay the same size because of that 1. All right, so the negative, it has the effect of multiplying each y-coordinate in the original graph of f of x by -1. All right, so you can do that. Take a few. What you do is take a few points off of figure 32, find their coordinates, and multiply each y-coordinate by -1, and then plot those points, and then connect the dots with a nice curve, and you get this result. Okay, number 81. Hey, the last problem. Honey, get the shrimp on the Barbie. I'm about there. All right, so let's take a look at this. G of x equals f of x minus 2. All right. So f of x again is the original f of x in figure 32 in your book, which I showed you a while back. All right. Well, this has the effect of a shift to the right. Right because it's next to the x here. 2 units to the right. Okay. So what I'm going to do is take a few points that are on the original graph f of x and apply that shift to the x coordinates. You just add 2 to each x coordinate. Alright, so we have the point 0, 5 on the original graph, add 2 to the x coordinate, and you get 2, 5. Alright? And we have the point negative 2, 0. Add 2 to the x coordinate, you get 0, 0. Alright? And then 2, 0. That becomes 4, 0. Negative 4, negative 5. Negative 4 plus 2 is negative 2, so you get negative 2, negative 5. One more. 4, negative 5. The shrimp is burning. Let's hurry. You get 4 plus 2 is 6, so 6, negative 5. Alright. Now, warning, danger, Will Robinson, danger. The answer in your book is incorrect. The book's graph is incorrect. Okay. I downloaded my book in summer of 2018, so maybe yours, if you downloaded it later, has the correction applied, alright? But I drew the correct graph in red, and I used these points, as you can see here, plotted those and connected the dots. So in red is the correct graph right there, above the graph that's in the book, which is not correct. So if you look at the points that have been transformed, you'll see right away that the book's graph is not correct, at least in this edition of the book. Alright, so watch out, watch out. There you go. Alright. Well, that takes care of section 1.5. It's been real. Now you can go relax as I can and have my shrimp on the Barbie or whatever. Have a drink. Pat yourself on the back for a job well done, and take life easy until we get back, and we'll get into the next section, 1.6. We're almost done with chapter 1. How about that? Wow. It's taking quite a while to get through these chapters or sections, doesn't it? But yeah, you should see all the work I have to do to get this thing done. But hey, I'm having fun with this. So it's not really work, is it? Alright, so you guys take it easy, and I'll see you later.